There we go. Perfect. You guys should be ready to rock and roll. So when we started a couple classes ago, a couple lessons ago, when we started talking about solving word problems, remember we had a little 5-step word problem solving method, and we talked about how you got to figure out what the question's asking, assign a variable, write an equation, solve an equation, answer a question. Just that simple, right? And then we took a look more recently, I believe it was on Tuesday, at a couple of applications, right? We talked about consecutive integers problems, and then we just started talking about percentages and how the word of means multiply, the word is means equals, the words what number or what percent means we use a variable, all that good stuff. So today we're going to kind of follow that up with some more percentage word problems, okay? Some more percentage word problems. What I've got in the red box here that you guys should see on your screen, go ahead and jot that down, and let's commit that to memory. And this actually harkens back to what I believe Jake was talking about, if I remember who it was correctly, where you can set up what's called a proportion, okay? And you can solve a lot of these percentage word problems with a proportion, all right? So what's in the red box is actually what's called a proportion. It's where you've got one fraction equaling another fraction. Okay, and the way that we would solve a proportion is, you jot this down as well, I hope, the way that we would solve a proportion is through cross multiply, okay? Or if the unknown is up top, simply just multiplying by the denominator of that unknown fraction. Okay, question? Oh, you might have heard George outside? Well, let's go see. There he is. George, your classmates have better ears than I do. They heard you outside. Come on in. What in tarnation do you expected me to let you do? You need to get in. Coach Cannon's door is closed. He's not here. Yeah. You guys think y'all run this place, don't you? You boys. Y'all think y'all run this. What are you doing? You're helping? All of you guys? It takes this many people to do t-shirts in Spanish. What do you want? What about Shelton? Who is Shelton? Shelton? What are you doing for Mrs. Shelton? Getting extra help. She don't look like she's here, bro. The door's closed. Are you sure? The math lab is open down there on the left, 108. And what are you doing? Spanish. Goodness gracious. I must be a doorman. Hey, Victor. How are you? Good. What's your reason for being here? Spanish? Good. All right, come on in, brother. Glad to see you. Hey, we need to pray for Trip, by the way. He emailed me last night, said he thinks he's got corona. He is feeling terrible. Oh, me. Did y'all hear all that? Yeah. I love being mean to people. Just because I'm not really being mean, I'm just giving them a hard time and watching them squirm. What were we just saying, by the way? How do you solve a proportion? You cross multiply, okay? So when it's a fraction that equals another fraction, that's exactly what we're going to do. The trouble here is we've got to make sure we set up our proportion appropriately, okay? So example 7 talks about the IRS, and it says it increased the deductible mileage cost 55 cents a mile from 51 cents a mile, okay? So first of all, you got to make sense of the past and the present with these problems. What was it in the past? It was 51. Now it's 55 and a half. So we want to be able to calculate the difference. In your notes, I want you to write down that the little symbol that I've got right there, that triangle, does anybody know what Greek letter that is? There's a university down in, I believe it's Cleveland, Mississippi, where they are the Fighting Okra, or the Statesmen. Anybody know what the university that is? Delta State. And this little symbol right here is delta, and it stands for or represents change, okay, or the amount of change. So delta, like if I said delta x, that's the change in x. If I said delta y, that's the change in y. And you guys will actually see those expressions later on this year when we start talking about the slope of a line. But for us right now, this just means, generally speaking, what's the change? So how much did the IRS change their allowable mileage deduction? From 51 to 55.5. What was that amount of change? 4.5 cents per mile. Good. So that's going to be what I put up there at the top of my equation. Okay. So here's my proportion. Okay. So 4.5 cents. Again, we get that by subtracting. You want to write that down. The amount of change you get by subtracting. And you can say that's either the original minus the new, or vice versa, okay? The original minus the new if it's decreasing, or the new minus the original if it was an increase, okay? And I put it in absolute value just to make sure that we don't represent delta as being negative. We just keep it positive, okay? All right, so the amount of change, that's what delta stands for. That's what we calculate. That's one out of our 4 parameters. Look at the second fraction's denominator, and Lewis, tell me what that should be. It should be the original amount, which would be what?
51.
Very good, 51. And fellas, that is uber important. Sometimes students want to put the new amount down there. No, no, no. What we do is we represent the amount of the ratio of the amount of change over what it was originally. That's how you compare growth. Okay? Like last year, let's say last year I made 5 birdies when I played golf. I don't shoot golf very well, so I rarely make birdies. Let's say last year, the whole year, I made 5 birdies, and then this year I made 7 birdies, right? I changed by 2, but I'm not going to put 2 over 7. That doesn't represent accurately the amount of change. It would need to be 2 over 5. I increased my birdie percentage by 40%. It's 2 over 5, not 2 over 7, for example. Okay, just making that kind of thing up there. So we've got 4.5 over 51. And then last but not least, this question says, find the percent change, right? So if we follow our 5-step word problem solving method, you know, it says find the percent change. That's what we're looking for. We want to let our variable stand for that. So I'm going to set X as my unknown amount of percent. 100 stays the same because that's always what it is, because it's percent. And now we've done steps 1, 2, and 3. We've written our equation. Step 4, we need to solve that equation, and we're going to do that by cross multiplying. Channel your inner Fruit Ninja. Did you guys, Jack, y'all ever play Fruit Ninja? You know what I'm talking about? Yeah, some of you guys are nodding. Yeah, Alex knows what I'm talking about. That's like where you had the little phone app, and they would throw up a piece of fruit, and you'd swipe it. And then my favorite part was the pomegranate, Nate. You know what you would have to do on the pomegranate? You remember? Yeah, Joey's doing it's like you just have to slice it a bazillion times because apparently pomegranates are knife resistant. But anyway, we're gonna cross multiply. Channel your inner Fruit Ninja there, George, and we're gonna cross multiply. So we got x times 51, that's 51x, and we got 100 times 4.5, so that's going to be 450. Okay, and then what would my last step be, Mr. Reed Johnston? What do I need to do to solve that? There we go. So we're going to divide both sides by 51. Okay. Now 450 divided by 51. Let's see here. Probably not going to work out nice and neat. I don't think it does, at least. Why don't I try it on my old calculator? 450 divided by 51 equals 8.8, thereabouts. Now it does say round to the nearest tenth. So if it's 8.82, I'm going to just round to 8.8. And that is the percentage of change. Okay, that's the percent of change. Now I say memorize that formula ASAP. It is a very important formula because you'll use it for all different kinds of stuff. Okay, you'll use it for all different kinds of percent change formulas, or word problems, excuse me. Okay, let's look at example 8. You guys give this one a try. So read the problem. You don't have to write it down verbatim. You have to write all the words down. But I would encourage you to focus on the major parts. All right. So I see an original cost of $7.50. That's important. I see a markup of 40%. So that's an increase. And then it says, please find the amount of his new listing price, as well as how much he raised it by. So they're asking us for 2 things. All right, so take a couple minutes, see if you can consider the answer to both those questions. All right, Paul, you're going to help me set up my proportion, okay, Mr. Camilla? So,
Okay.
what goes on the top left?
Would it be the percent?
You
No, the
tell me.
change. The change.
I'm asking the questions here, son. Top left is going to be what? Look at your formula that we wrote down. Top left, I need what?
It would be the change of the original minus new.
Dadgummit, bro. Dude, the top left-hand corner, does that
Oh,
look like?
top left. My mistake. Would it be X?
No, it's not going to be X. Look at what I've got on my screen here. You see what I'm circling? What symbol is that?
I don't know.
Okay, in your defense, I did write it kind of goofy. Here, how about that? What symbol is it?
Percent.
Yeah. Sometimes I rush my percents and I connect the little dot on the top. Y'all ever see that? You guys, okay, so just FYI, if I write it quickly, I apologize. All right, so Paul, that's what I want you to put in the top left-hand corner. What is my percent?
40.
40%. Okay, very good. Now we're going to dish this off to, let's see here, John Zweig. What goes on the bottom left?
100.
100. Okay, good. Paul, you can mute yourself, by the way. All right, let's go with Colin. What's going to go in the bottom right-hand corner, Mr. Kozlowski? Is he the one that always has
40.
trouble? No, he doesn't. He's got it today. Okay, good. What goes in the bottom right-hand corner?
40. Wait, no, it's 0.4.
Once again, looking at this formula, what goes in the bottom right-hand corner is the original amount. Okay, so when I've got the word original highlighted in blue, it would probably mean that in the bottom right-hand corner, I need to put what?
750.
That boy, 750. Okay, good. So really, fellas, what we're doing is we're plugging in 3 parameters that we know, and then we're going to have 1 parameter that we don't know. Okay. Now, this parameter that we don't know is the amount of the markup or the amount of change, right? Our delta. Okay. So I'm going to try to get you guys to be a little bit clever about this. Instead of just plopping down and putting like an X on the top of this, let's try and be a little bit more clever. What did we say that delta equaled? Do you guys remember what we told it? It was an absolute value. It was something minus something else. What is it? What do you think, Nate? New minus original or original minus new, depending on if it's a markup or if it's a markdown, right? So if it's a markup, as it is in this case, the new is going to be more than the original, isn't it? Okay, so I'm going to say let X equal the new listing price, because that's one of the 2 things that they're asking right there, isn't it? The new listing price. So if I let X be my new listing price, then as Nate said, I can use subtraction. I could say, okay, they marked it up, so that new listing price is going to be more than the original price of $750. Okay, so I'll let you chew on this for a little bit, and the notion of not just slapping down a variable on the top can be a little bit of a challenge for you, but I want you to remember, as we just quoted, that delta is the same thing as the difference between the new and the original, or the original and the new. Okay, now how do we go about solving this? Cross multiply. Except in this case, and I'm wondering if anybody spots this, there might be something that I could do that would make it a little bit easier with my cross multiplying. George? Which zeros? Oh, be careful. Which zeros? Oh, drat. I knew you were going to say that, dadgummit, George. You let me down. What does this minus sign act as? A barrier? Have I dadgum called it a barrier grove? What is this? What is this? It's a roadblock. And what it does is it says, don't do anything crazy here, George. Don't you dare cancel out zeros just because you see zeros at the top and bottom. I mean, heck, in that rationale, we could just say, well, let's just scrap the whole 750 since I see 750 on the top and the bottom. But nay, we can't do that. Here's why we don't want to do that. That minus sign links these 2 terms together. Notice I use the word term. Term starts with a T. T looks like a plus sign, so plus and minus signs, right? Those are, what are they, George? Roadblocks. Okay, they say don't cancel terms out. Only cancel common factors. So I like the idea that you had about canceling the zeros over here, because 40 is the same thing as 4 times 10. And 100 is the same thing as 10 times 10. And those now are factors. And we can go ahead and kill off the two tens right there. And truth be told, I probably wouldn't write it like that. I would probably just say, you know, back in the original problem, remember how it was 40 over 100, right? I'd probably just kill off the zeros, just scratch those out just like that. But we can't do it on the right side because the minus sign acts as a roadblock. All right. We could also take the 4 and the 10 a little bit further, right? We could take out a 2, and we get 2/5. 2/5, okay? Now we're ready. Now we're ready. So let's do our little cross multiply. Actually, let me clean this all up if you don't mind. I'm just going to put 2/5 right here, because that's what 40 over 100 is. That's what 40% is, 2/5, right? So we're going to cross multiply. Let's do it. 2 times 750. How much is that? 1,500. All right. And then, Tiago, what property am I going to have to use when I multiply my 5 times that numerator?
Can you say that again?
Yes, what property am I going to have to use when I want to multiply my 5 right here times this numerator?
Distributive?
Yeah, very good. We're going to distribute that 5. So let's do that. 5 times x is 5x. And then 5 times negative 750. Let's see here. What's that going to give me? Is that 5,750? What'd you get, Jack? 3,750. Does anybody concur with that? Yeah, we got a couple guys that are concurring. Don't just concur just because you think it's right. You better concur because you know it's right. Say it again, Jack. 3,750. I think that sounds just about fine to me. Now, we've got an equation here with which we could easily solve with 2 steps. Okay, so let's get Joe Edwards to tell me those 2 steps.
You need to isolate the variable by adding 3,750 to 1,500 and then divide it by 5.
Perfect. 3,750 and 1,500. So that's going to be 5,250. Is that right? Is that right, you guys? Yeah. All right, and then we'll divide by 5. So 5 will go into that. 1,050, maybe? 1,500 equals that divided by 5. Yay, 1,050. And 50. Now, we've just done which step of our process?
Of the equation?
Yeah, step 4. We just did step 4. We know there's a 5th step. What is that 5th step? Answer the question, or solve. You know, I knew what you meant. Yeah, answer the question. So what we want to do is go back where I've got it highlighted kind of in that fuchsia color. It says, find the amount of his markup, okay? So if the new price was $1,050 and the old price was $750, then what is the amount of the markup? What do you guys think? $300. All right, so 1050 is the new price, which he had marked up by $300, which was how much of a markup percent-wise? 40%. Very good. Now 300 is not 40% of 1050. What is 300 40% of? 750. Good, the original amount. Fellas, I'm telling you what, man, making sense of percentage problems is really important in this world, because oftentimes, especially in a consumer-based economy, oftentimes we're out and about and we're having to make like intelligent consumer type decisions based on percentages. Okay, I'll give you a perfectly good example. Mrs. Morgan, who I love dearly, she likes to shop sometimes a little too much, but hopefully she's not watching this screencast. But like, she'll go to Macy's, let's say. I use Macy's as an example. And Paul, I'll get your question in just a second when I finish my little spiel here. She'll go to Macy's and they'll say something to the effect of, hey, Mrs. Morgan, if you want, you can take 40% off of this particular item. Let's say she's going to buy I don't know, a new set of dishes at Macy's. You can get 40% off this new set of dishes. It's on sale. And so I'm like, okay, that sounds pretty good, honey. And then the salesperson says, and if you use your Macy's credit card, we'll let you have an additional 10% off. Okay, so what does Miss Morgan think the final sale price is or percentage price is? Mrs. Morgan thinks it's 50%, and that's very alluring. That's very tempting, right? But it's not actually 50%. Okay, because what they do is let's say this thing of dishes, just to make this example up. I'll say let's say the set of dishes costs $100, right? After the first 40% off, now how much does it cost? It now costs $60. Okay, and then they're going to take an additional 10% off, but they're not taking the additional 10% off of 100, for instance. They're taking the 10% off of 60. So how much would that cost? $54, which is still a pretty good deal, right? But it's not the 50% that we would think. So like that's just a small example, just small potatoes here, right? Where you guys want to be informed consumers, you want to be smart about percentages, and you want to be able to have memorized this formula up here that's boxed in red there. And I've already, just kind of doing a Q&A today, I've already noticed a few of you guys seem to be struggling with the notion of that proportion there. So please, please, please memorize that proportion, and let's practice using it. All right, Paul, go ahead with your question.
How did you get 300 as the markup?
Oh, okay, good. The amount of change, our markup is the difference between the original price and the new price. Okay, so if the original price was $7.50 and we calculated our new price to be $10.50, that's how we got our markup.
Oh, okay.
The difference between those two. The difference between those two. Good question, Paul. Anybody else with questions?
I have a question.
Oh, go ahead, Jake.
Couldn't you just multiply 750 by 0.4?
Yes, absolutely. Absolutely. So the question there was kind of phrasing it like y'all remember the problems that we worked in class on Tuesday? They were like, what is 40% of 750? That's a different way of phrasing this. So like if we ask the question, what is 40% of 750? And we translated that into an equation, right? What would that equation be? That would be x equals 0.4 times 750. And we run those numbers, and that's where we get our discounted price of 300. And then all I would need Jake to do after that would be to what? To find my new price.
Add 300 to 750.
Absolutely. So to kind of go around the other way. And one of the things you guys will find, I like this about algebra, is that there's oftentimes more than one route to the solution of a problem. Okay? And necessarily the route that I show you might not be one that you are as comfy with or that you like doing as much. And sometimes it might seem like we're taking the long way around the barn, so to speak. So if you have a different approach that you like to use or that you've been taught to use, absolutely feel free to use that. But I do challenge you, be versatile such that you can do it both ways, okay? Because knowing how to attack a problem from multiple directions will make you a stronger student, because you might encounter, so like Jake, we might encounter a word problem someday that is not solvable using that approach that you mentioned, and we would want to be able to fall back upon this approach using this formula. So fabulous question. All right, are we ready to talk about money? Yes, we are. Okay, so check this out. I don't know if you guys have experience with the notion of interest, okay? But interest is, this notion of interest is that if I borrow your money for a period of time, and then I pay you your money back, I also need to pay you some extra money because you were nice and you let me borrow it. Okay, that's what the notion of interest is. Okay? Does anybody, you guys study the Bible? Y'all know what charging too much interest? It's a sin in the Bible to charge an exorbitant amount of interest. Anybody know what that's called? You ever heard of usury?
Is that called extortion?
Not extortion. Good guess. It's called usury. Usury would be like if Alex said, Coach Morgan, can I borrow $20? And I'm like, yeah, sure. Here's $20. Tomorrow you owe me $40. You know what I mean? So I would be guilty of usury in that case, and that would not be very nice at all. All right, but I want you to write down these four, I'd say vocab words, really just these four parameters to what's called simple interest. The way to calculate simple interest, okay, is just to multiply the principal times the rate times the time. Now let's make sure we understand what principal means. First of all, principal is the amount borrowed or invested. Like, so if I went to the bank, if I went to good old Bancorp South out in Oakland, where we do our banking, and I said, hey, Bancorp South, I'll give you $1,000. Please hold on to it for me, right? They're going to pay me interest. They're going to say, oh, sure, we'll pay you 0.5% point of interest on this. And so the 0.5% interest would be my rate, right? So your rate is going to be the percent that the amount of amount's not a good word, and I don't want to use a rate to define rate. So we'll just say that percent is, or rather the rate is the percent at which you're getting charged or you're getting paid interest. So like Bancorp South might pay me 0.5%. And then let's say that George rolls up in there to Bancorp South and says, hey, can I have a small business loan? I'm going to start at, oh, hey, Grady. No, that's tomorrow, like usual. Coach Smith is going to do it with you guys tomorrow. So I'm just going to do today's. Speak of the devil. So let's say George rolls up in there and he says, hey, I want to start an ice cream stand outside of Christian Brothers. I need $1,000. And they say, sure, we'll lend you $1,000. We'll charge you 2% interest, okay, for that small business loan. That's how a bank makes money. They lend me, or rather they take my money and they pay me like 0.5, and then they lend it to George and they charge him 2%, right? So that's the idea. That's how one of the ways that a bank might make money. And of course, time is how long the investment goes, how long the loan goes. So those are our parameters, okay? And then I, of course, is the amount of interest, the amount of that extra money that we would owe. Am I preaching to the choir here? Do you guys already know all this? No? Y'all hadn't dealt much with interest? Hopefully you'll find it interesting. Oh! Jack, you knew that was coming, didn't you? Oh, my goodness. All right, let's look at example 9. All right, so Ariel invested $950 in her bank, and it earned simple interest at a rate of 3%. Okay, how much interest did she earn after 7 years? So, by the way, the amount of time is in terms of years here. I didn't mention that earlier. There are different types of interest. So, like simple interest is simple. Compound interest is a little bit more challenging, and it's got different parameters. But for simple interest, they just calculate it once a year. So like you leave the money in the bank a year, and then they say, okay, after this one whole year, here's your interest. Check. And then so on and so forth. All right, so let's see here. What is 950? Okay, so what is 950? Will Edwards, what's that called? Well, use one of these 4 vocab words right here. Good, the principal. That's our principal investment. Okay, so $950 is her principal investment. This question says, how much interest did she earn? That's what they're trying to tell us to figure out, right? So I'm going to let I be the amount of interest earned, and therefore my formula, I equals, okay, so 950, right? That's her principal investment. Thank you, Mr. Edwards. Okay, Andrew, what's my rate going to be? I know that's the next parameter in the equation. What's my rate going to be?
3%.
Okay, now here's the question. Should I write 3 down?
No.
What do you mean no? Why not? Very good, because what do we do when we're calculating with percentages? We express them as decimals. Very good. So we would say point or 0.03. That's my rate, okay? And then last but not least, what do I plug in?
7.
Plug in a 7. Very good. So 7 years. And again, this is nice to have a calculator when you guys are running these decimal numbers. So $950 times 0.03 times 0.03 times 7 equals 199.5. That's actually not approximately, that's equal to. So $199 50 cents. Okay. So here's my question. It says, how much interest did she earn? Okay, we've answered their question. Now I want you to tell me what the answer to my question. After this 7 years, Coach Dollar, what can I do for you?
Just got one quick thing to say.
It's recording, so FYI.
What kind of friend doesn't give the other friend a 3.5 foot putt for the victory? You gotta tell him it's good. Give him a gimme.
Get out of here. Good grief. Coach Smith yesterday, his lowest score ever is 83. Okay. And so he rolls up onto the 18th green, and he's at 80 strokes. Okay. So he's about to make an 81, but he's off the green, and he's got a chip and putt. Okay. And he'll have an 82. And so he's off the green, and he chips, and he gets it about 3.5 feet. So he's at 81 now. And so 3.5 feet, if he makes that putt, he gets his 82, and he breaks his low score ever. And Coach Dollar apparently thinks I should have given that to him, which I disagree. But whatever. Maybe I'm just cold-hearted like that. He beat me anyway. I ended up with a 93. All right, so my question for you guys here, now that I've been thoroughly distracted, is how much money does does Ariel have after 7 years altogether? What do you think, Jack?
1,149.
And how'd you get that?
I added.
Yeah. She came back, and maybe she withdrew all of the money from the entire account. She's not just going to withdraw the interest. She's also going to withdraw the original $950. Okay? Let's see here. We'll have to save this one for next time. We'll use it as a warm-up question for next time. We're done with 2.2, and we'll start 2.3, manipulating some formulas tomorrow. But y'all remind me, and we'll do this last example as a warm-up. Thank you so much for a great class, fellas. Y'all can skedaddle on out of here. Live Jesus in our hearts. All right, thank you, and I will see y'all tomorrow.